that the sum of a sequence is just every value inside of that sequence added together. But have you ever thought of adding every single positive integer or natural number together until infinity? Well, it's weird to think about it, but this answer is actually negative 1 over 12. It's amazing. So, how we are going to try to explain this to you is by creating three sums. So, of course, first of all, the sum S is just the sum which is represented above using sigma notation. And this is just all the sum of all numbers until infinity. Natural numbers until infinity. Yes? With this we call S. S1 is another sum. This sum is written as 1 minus 1 plus 1 minus 1 plus 1 minus 1 until infinity. So it doesn't change. It's basically just recurring, but this happens infinitely. Then S2 is 1 minus 2 plus 3 minus 4 plus 5 minus 6, and then, of course, until infinity. So, first of all, we want to try to look at sum 1 and understand it. So, if the amount of numbers in the sequence, in the series, is 1, then we'll end up that the answer to this series is 1. But if it ends on an even number, 2, 4, or 6, or 8, then we'll see that the answer to this sum is 0, because 1 minus 1 is 0. Well, that to know the answer to the sum to infinity, we can just approximate this to be 1 over 2. And well, you can also prove this in a more complex way. I'm going to leave that to another video, or a good video to watch is a video from Numberphile. I would recommend to watch that. It's very handy. So now we know that sum of this, the answer to this sum is 1 half. Next, we're going to look at sum 2. For this sum, we're going to add two of these sums together. So we're going to write this down another time. Okay, and then we're just going to add these two together. However, before we're going to do that, we're going to shift this bottom one to the right. And we can do this because it's until infinity, so it won't have any effect on the numbers. It will just, you can just shift it to the right, because it won't have any effect on the numbers which are available, because it's always infinity. Infinity doesn't change. So now if we add them, well, of course, the 1 just stays a 1. The 2 becomes a minus 1. This becomes plus 1. This becomes minus 1. This becomes plus 1. This becomes minus 1. And so forth until infinity. And well, we can see, 2s, or just adding them together, gives us S1, what we said here. And now we know that S1 is 1 half, so 2S2 equals S1, or 1 half, and S2 is therefore 1 over 4. So now we're getting close to the answer. Well, so if we go back to the equation S, we want to try to do something to the equation to simplify it a little bit. So let's subtract that by the second equation, S2. So if we write that down, 1 plus 2 plus 3 plus 4, and so on until infinity. And then you subtract 1 minus 2 plus 3 minus 4 plus 5, okay, and then until infinity. So 1 minus 1 is just 0, it just disappears. Then this becomes 2 minus 2 is 4, this 3 minus 3 is 0, 4 minus 4 is 8, and then this is 0 for the 5, and this becomes a 12. And you can basically just remove the zeros and you go with this equation until infinity, because infinity is always infinity, and if you add numbers to infinity, it will still be the same. It will still be infinity. And well, if we take out a factor, a 4, we can see that it will just have the same equation, or the same series as this, the original formula, or the original series. So now we can write that s minus s2 is 4 times s. And we know that s2, if we go back here, is 1 over 4. We can say that s minus 1 over 4 is 4s. And now if we subtract s from both sides, negative 1 over 4 is 3s. And now you can already see where this is going. S is eventually, if you divide both sides by 3, negative 1 over 12. So the sum from every value, every natural number, or every positive integer is negative 1 over 12. Amazing.